Welcome back again. Today we have we are in the chapter 2. I remember we record something here. Till the subspace. Do you remember that? Chapter 2. We see till subspace. So I'm going to start from there to the other side. Venn diagram subspace. We stopped here. I remember in the previous session we were there. So now we have a subspace. What's the definition of subspace? How we understand from the subspace? Look at here, dears. For subspace, for example, we have a space like A, B, C, and we have a small things like B. We have only A. We say that for each element in B should be an element, or then this element should be in A. What do you mean by that? Look at that A and that B. We have a set B which contain only one element, right? A. Then you can find small a in the biggest or capital A, right? So it means that here's element, that element is here. How about if I have a C, I have C is equal to AB. Of course, we can say that C also is a subset of B. That's the symbol of the subset, okay? And if I have D equal to AF, tell me about, is D subset of A or not? No. Why? Because if there exists an element, we say that if you have a one element that make your theorem, make your definition false, all will be false. So we have at least M such that F belong to D, but F does not belong to A. Am I right? That's it. So depending on these examples, you understand if I have a small space, small subset, it should be all element in the large one, the universal one. Understood? Good. And phi is the subset for all or any subset that you like to see. A, B, C, U, Z, anything. If you like it, phi is the subset. This is the first. The second fact, each subset is the subset of itself, right? Can you imagine? Each subset. For example, bring the real numbers. Real number are subset in itself. Am I right? Why? Because each element here is there. So that means that satisfying the definition. Do you have any comment, any things on, what do you say, on the subset? Dears? No question? Yes, Kakal. You mean here? Empty is subset of itself. Like that? Yes, of course. By two properties. Each set subset itself, or phi is subset for all sets. By two things we can answer that one. Good, thank you. What else? Good. Now we have a definition. You can see we have a set. Let me use the other one. Discrete, chapter 2. That one's better. Okay. Now you can see these two facts. Phi subset for each set and each set subset of itself. Of course, the proof is not include. Kindly cross it. And later don't send email for me because I cannot answer. Understood, dears? Good. Now we have a Venn diagram to show the subset. I think we did that before. We know that Z, we say that natural number is the subset of Z and subset for Q, and all of them subset of R. Am I right? You can show me by the diagram. That's N, That's Z, right? That's Q, and all is R. You can write down like that. Am I right? So we can use Venn diagram to show that the subspace or not. And of course, we have what we say two sets. Listen to me. Two sets are equal. So I say A equal to B if and only if. Look, if and only if A subset of B and B subset of A. So if I say two sets are equal, calculator not allowed actually. So if we have two sets of, we say equal, in that case means that they are subset of each other. Understood, dears? Good. And how about something else? Yeah, we have like that. Now we have size of set. Size of set. For example, if I have, and you know, this is the concept, property. Then later, like a chapter 1, we are going to use it in the final one, in the final section. Now, if I have a set of A like AB2, if you ask me about the size of the set, means that how many elements do we have here? How's the answer? You can write down like a hash A, which is called cardinality. It's called cardinality. Or you can write down like S, absolute of S. Actually, we are going to use that one more than the other. So it's called what you say is equal to 3. How many elements do we have? 3. The same thing you can write down here like that. So here we are, we have a cardinality. Look at the set. Look at the set. You say what? Let A, listen to me, there's a quiz, like a quiz question, like a test question, kindly. You say what? Let A, okay, be what? Let A be odd positive integer. So I have Z O positive less than 10, less than 10. So tell me about A. A is belong to Z O positive and another condition. A is what? Less than 10. The elements on A. So tell me about the set of A. 1, 3, 5, 7, 9. You are right. So tell me about the cardinality of A. 5. Understood? Now it's clear. And of course, SB, the set of letter in English, you know, we have a 26. Of course, we have an infinite and finite set, you know. Maybe the set of A, we say is A is equal to 1, 2, 3, and go on, like a natural number set, right? And we know maybe 0. We know these sets are infinite. We cannot stop. So we have 3 dots, means that stop. So tell me about of n equal to what? Infinite. You're right. We have no, cannot count it. It's 1, 2, and go on. So we don't have the, for infinite set, we don't have a cardinality, but for finite, we can find the cardinality. Understood, dear? Till here is clear. Now we have another things. And equal actually is good for your branch for computer science or engineering. Why? Because we have what we have. We have power sets. What's power set? Something, for example, if you have A equal to 1 and 2, if I say find power of A, means that you have 2 to power 2. So power set is 2 to power something, member of the elements, or number of the, or let me say cardinality. So in A, I have what? I have 2 to power 2, right? What's equal to 4. So kindly show me the set. What do you mean by 4? That 4 is for what? I say each set has got phi in it, right? Am I right? Each set, there's a space in it. Okay. Now I have single A alone. Am I right? Or again, single 2 alone, or the set itself. In your lecture note, write down like 1 and 2 together, like the set. So I'm going to say phi and A and the elements. This is how many elements do we have? Cardinality of it. cardinality of power A is equal to what? 4. Now you understand what do you mean by power. So look at this example. We have a power set. Look at this example kindly. Check. So tell me about that one. How many elements do we have? Yalla.
3 elements.
Right? 3 elements. So I have just A, B, or anything. B. Let's push. We have a 0, 1, 2. Right? Okay, 0, 1, 2. So tell me about power of B. 2 to power 3, 8. Am I right? So how about the 8 elements? I say power of B equal to phi, then single A, 0, sorry, single 1, single 2, then what else? 0 and 1, you are right. Together, 0 and 1, 0 and 2, 1 and 2, what else? 0 and what? 0, 1, 2, or B itself. Am I right? Tamam. So how many elements? 3, 6, 8. You got it, dears? Good. Good for you. So here we are. Here's the power. Now we have what? Again, phi. So if my set is equal to phi, let's say S equal to phi. So give me the power of S. 2 to power what? 2 to power 0, you are right. I remember I told you that the cardinality of phi is 0. So 2 to power 0 equal to 1. So can you show me P of S is equal to what? Only phi in it, right? And you remember that folder, or let me say empty folder. Understood? How about if in the exam I say find if H or M equal to phi, okay, find P of M. What do you think? How many elements do we have? Yalla, think about it. Do you have one? We have? How many elements in M? Just tell me. One empty, right? One empty. We say that. We have one. Because find, so we have a folder with nothing, so we have one. And 2 to power 1, it will be 2. So show me the P of M. I say phi and the set of M. Am I right? Set of M is like what? I can write down like that. M. And you know, the shape is like that. So how many elements do you have? 2. You got it, dears? So how about P of M? The same. Phi over phi over phi. What do you mean by that? It means that you have a folder, another folder in it, another folder in it. Does not make a sense, but we have things. We have elements. You got it, dear? Yes? Yes, Kak. Any questions, dears? Kaka, clear? Now you can think about that when you understand what's going on, right? We have an empty folder, which we did, or we make a new empty folder. So that's mean like that. Clear, dears? Okay, now we have a Cartesian or coordinate. We heard about coordinate in the Calto. We have a polar coordinate, Cartesian coordinate. Here we have only Cartesian coordinate. And you know, if I have a x and y, I have a Cartesian coordinate between x and y. We say that point is 1 and 2, means that here's 1, here's 2. Am I right? So the first location for the first set, the second location for the second set. So if you ask me about how to find this, I say 1 and 2 is between, after crossing x to y, sorry. After crossing this set, I got Cartesian product, okay? Why? Is that change, does that make a sense if I say y cross x? Of course. The location, the pair will reverse, sweep, right? So we are not talking about, for now, I'm just going to talk about x multiply y. Now we have a general case. We have a tuples or tuples, means that how many orders we have. A1, A2, A3, how many? What do you mean? For example, if I am talking about 2 dimensions, I know my members or my vectors is like what? Is like 1 and 2. Am I right? This is in 2 dimensions. How about if I'm talking about W in 3 dimensions? How's the elements? 1, 2, 3, right? A, B, C. Understood? That's much. Right? Understood, dears? So in that case, we have A, B, C. So how about if I have 4 dimensions, 5 dimensions? So it's going about A1, A2, A3 till AN. Clear? Why we study that one? Because later we are going to cross many things together. Like what? Like this example, look. This is the definition. Look at here, and you know the definition is very important. We say A cross B means that we are going to get order pairs such that first order, first location is for set A and second location for B. Okay. Now give me an example to get more things. Here's the example. I have A12. We have A equal to 1 and 2 and B equal to what? A, B, C. Am I right? So give me A cross B equal to what? Yalla. A cross B is equal to what? We say cross is what? Multiplication between the first with the first with the second. So how? Yeah. 1A, 1B, 1C, not ABC, because means if you say ABC means that you just multiplied. This is the number. No, now I'm talking about crossing 2 sets, not number. Now 2A, 2B, 2C. Clear, dears? Understood? Come on. How about if I say B cross A? I'll get what? A1, you are right. A2, B1, exactly. B2, C1, and final one, C2. And you can see A cross B is not equal to what? B cross A. Am I right? Because the location will change. The cross is something else, not just only multiplication. So we can say cross is not commutative. Is not commutative or symmetry. Clear, dears? This one will be in the exam. I see, for example, all cross multiplication are symmetry, or A cross B equal to B cross A. If you say yes, prove it directly or by use direct. If you say it's not, give me an example. So you'll give me the example, any example that you like. Clear, dears? Good. And of course, you can see from here that one is good. Now we have a BA, which is different with them. Now, how about A1, A2? Means that if I have many sets, A2, 3, 4, so it's okay. A1, A1, look the location, A2 in A2, A3 in A3. What do you mean by that? A equal to that one. Just let me bring it. يلا يا جماعة. find A cross B cross C. Can you imagine? يلا دي. A cross B cross C is equal to 0 exactly. Yeah? 1 0, you are right. 0 1 1 1 2. Okay. 0 2 0 0 2 1 0 2 2. You are right. Wait. Yes. 1 1 0 1 1 1 1 1 2. تمام؟ تمام؟ No. 1 2 0 1 2 1 1 2 2. You are right. So how many elements do you have? Exactly. So I'm going to keep this in my mind. Then later I'm going to ask you something. So here we are. You can see you are right. 1 2 3 4 5 6 and 12 we have. Now, you see something here. That's what I'm going to ask you about it. You see that one is not equal to that one. Can you answer me? Of course, we have the answer off here. We did it together, right? Right now. So tell me about what's the difference between that one and that one. So kindly bring a paper and answer. Right now. You know what's the difference between saying and writing? Saying something, everyone knows, but when you are trying to write, it's not like that. Look at here, we have A cross B at the beginning, right? So A cross B is equal to what, if you remember? The set was what? 0 and 2, okay. We have 0 and 1, am I right? 0 and 2, what else? Tamam? Now we have this. We have this. Cross. Tamam? We will get what? 0 1. Wait. You all right about the number, but as putting element, you did a mistake. Only one student did a good or correct. Look, you have what? You say 0, and this is the first. So we have a cross between two sets, right? So this is the first location for A, or what do you say? Can you say W and Z? The Z location is here. The W set is here. So I'm going to write 0 1 with 0. Now understood? Understood? Now you know where's the mistake, right? وين مخو؟ هتخاف شاني عرب وصحكم. بس رقم خذها بنايك أو كاكا همي واي كردو. Sorry, recording. Okay. Anyway, look. The second element 0 1 with what? With 1. The third element 0 1 with what? With 2. And go on. So let me do it for you. This is from the first element. The other from the second element. You got it, dears? So that's why it's okay you don't know, but you got it. Now, how about the second element? We have 0 2 with something else, with 1, with 0, sorry, and go. You got the 12, you are right. You got a 0 2 0, you are right. But this element is the pair by single. Understood? You are not going to get a 3 dimension. You get a 2 dimensions. But the first element is 2, the second element is 1. Understood? Tamam? Good. Thank you. Now, How about a square? What do you mean by a square? We have a square. So it means that a cross a. I think that one's easy for you, right? For example, if a equal to 0 and 1 or 1 and 2, so a silent, silent, a cross a equal to 1 and 2 cross 1 and 2. So of course I will get 1 and 1, 1 and 2, 2 and 1, 2 and 2. Am I right? And close the state notification. Of course, for 3 and 4 and 5, you will get the same. Yes. Actually, I don't know, but you can do it. Maybe 12, the same 12, I think. Kindly cancel these two. Does not include for final. Yes. And we stop here. Yalnızda uçarak 100 maniye. Hazır evet. Yak uçarak sorry. Yak uçarak 100 maniye teyak kunichi yani. Güdün. Geçer. You'll see them. O easy, o da öyle. Ama da da diyor.